In this video, we're going to take a quick look at how to properly interpret correlations. Just because two variables happen to be mathematically related to each other in no way guarantees that A is causing B. Correlation is not causation. There are many instances where people were absolutely convinced that A was causing B, when in reality it turns out that A had absolutely nothing to do with B. Why? Because of what we call in statistics a lurking variable. This is a third variable in the background. It's not in your study, but it's impacting one or both of the factors that you're studying. Here are a couple cases of what we call spurious correlations. Case in point, ice cream cone sales mathematically are very highly correlated to drownings. Why is that? The lurking variable in this case happens to be a hot summer day. On a warm summer day, more ice cream is sold, more people swim, hence more people drown. Ice cream cone sales in no way are causing increased drownings. Here's another classic example. Umbrella sales happen to be very highly correlated to traffic accidents. What's going on? Are they popping open inside the car? Well, you probably guessed it. The lurking variable in this case is a rainy day. More umbrellas are sold on rainy days, and more traffic accidents happen to occur on rainy days. Perhaps the most classic example of this occurred back in the 1930s in the town of Oldenburg, when the number of storks observed was highly correlated to the number of babies born. Oddly, the storks were not bringing the babies. As it turns out, the babies were causing the storks. Why is that? In Oldenburg in the 1930s, people lived in multi-family homes. When they started having children, they needed more space, so they built more homes. To heat those homes? Fireplaces. What do fireplaces require? Chimneys. Where do storks nest? In chimneys. So it was not storks causing increased babies. It was babies causing increased chimneys, causing increased storks. So whenever we look at correlations, there are two things we must keep in mind. Number one, the statistical side of this. If they happen to be statistically highly correlated, that's one thing, but that in no way guarantees a cause-effect relationship. The other thing we need is your knowledge of the process that would corroborate a cause-effect relationship. But with both of these elements in place, then you can be comfortable on your project that the X factor you're studying is indeed a root cause of the Y variable in your project. Good luck using correlations.